So this question, it gives you a graph y equals to fx, and on the graph there are certain values of x equal to a, the function value is here. When x equal to b, the function value, the y value should be here, and so on, c, d. And the question tells you that f x equal to 0, the solution is x equal to w, which means when x equal to w, the function value, the y, equals to 0. Now, can you please use Newton's method to give an approximation which is the closest to x equal to w among these 4 points, x equal to a, b, c, or d? Which point would give you the closest approximation for this equation fx equal to 0, the closest to x equal to w? Okay, now our problem goes to what is Newton's method? What exactly is Newton's method? Let's have a revision about Newton's method. Here I have another graph, which is a parabola with the function y equals to fx. And according to the curve, from the graph you can see that fa, when the value of x equal to a, the function value, the y, equals to 0. So we know that fa equal to 0. Now the problem is we don't know what is the value of a, and we have to use some iteration to find out this value of a. So first of all, let's make a wild guess. Let's say we take the value of x1. We have x equal to x1. And then from this x1, we locate the point on the function on this y equal to fx on this graph, and we will find the corresponding y value. And here, the y value should be fx1. Therefore, we know that the coordinates of the point on the graph here, when x equal to x1, the y value should be fx1, and the coordinate should be x1 and fx1. And now, on this point, let's draw a tangent to this curve, to this parabola. Let's draw a tangent to it, this highlighted blue line here. When we draw the tangent to this point on this graph, we will have the tangent cut the x-axis at another point, which we name it as x2. And now x2, as you can see, is getting closer to a compared with x1. So it is a closer approximation to a than x1. We repeat the previous process again. From this x2, we locate the point on the y equal to fx, this parabola. We locate this point, and we find the y value, which is fx2, and then we draw another tangent to this point and extend the tangent. You have to draw to cut it at the x-axis, and then we will get x3. And the x3 is obviously now getting closer to a than your previous two guess. And if we repeat this process again and again, you can see that we can have a pretty good guess, which is very close to the value of a. So although we don't know the value of a, but still we can locate a very close approximation to a. Mathematically, how do we get the value of x2? So first of all, we have to know that the slope of the tangent at this curve y equal to fx at this point, x1, fx1. The slope of it should be equal to the first derivative of this function, fx, at the point x equal to x1. This is the slope of this tangent, highlighted tangent. But at the same time, the slope of this tangent can be calculated by any 2 points on this straight line. And now we have 2 points. The first one is the x2, 0. And the second point is the point that we located on this curve, x1 and fx1. The slope of the straight line can also be calculated like this, 0 minus fx1 over x2 minus x1. It should be equal to the slope that we get from derivative. So what have I done here is I get 2 points on the straight line, and the coordinate of this point should be x2, 0. The coordinate of the point that we located on the curve should be x1, fx1, and we calculate the gradient of the straight line. It should be 0 minus fx1 over x2 minus x1, the gradient of this straight line, and it should be equal to the first derivative of this curve at x equal to x1. So this equation is formed, and our target here is to find the value of x2. 0 minus fx1 should be minus fx1, right? And multiply this denominator to the right hand side, you will have the denominator moved, transposed to the right hand side, and then divided the f prime x1 down there, you will get another equation, which is x2 minus x1 equals to this fraction. And now again, by transposing x1 from right hand side to left hand side, you will change the sign from minus to plus. And so x2 should be equal to x1 minus sign is from here, minus function value of x1 divided by the first derivative value of f prime x1. So we get the value of x2 by our first guess of the value of x1, and then do some iteration to the function value, take the first derivative. By this equation, you will get the value of x2. By doing this process again and again, you will get a very close approximation for the value of a. This is what we call Newton's method. It tells you that if the nth approximation is xn, which has the derivative not equal to 0, then the next approximation should be given by this equation. So let's go back to our question 6. X equal to w, the function value equal to 0. We want to get an approximation which is the closest to this w to solve the fx equal to 0, this equation. Theoretically speaking, D should be the closest approximation to W, but the tangent at this point, at the point when x equal to D, it is a horizontal line, which means the first derivative at D should be equal to 0, which makes you nowhere. And therefore, what we can have now is the point C, which is next closest to W, and then from C there, we can draw a tangent to this curve and find the x intersection of our next approximation, which is closer to W. Therefore, C is the best point among these four to give you a good approximation 2w. Question number 7, it tells you that the velocity of a particle in meter per second is given by this equation. What is x? X is the displacement in meter from the origin. And the question asks you what is the acceleration of the particle at x equal to 1. Acceleration should be equals to dv over dt. And now, since v is in terms of x, so by chain rule, you should have this one. So dv over dx times dx over dt. And from the velocity displacement equation, dv over dx should be equals to 2x. And dx over dt should be equal to v. Now we have everything, we just put back, because the question asks for at x equal to 1 the acceleration. So when x equal to 1, v should be equals to 3. And therefore a should be equals to 2 times 1 times 3 equals to 6 meter per second square. The answer is C.